This is Beyond the Bot with 8931R Arsenic. Now, we are going to talk about the biggest, meatiest part of robotics, the engineering notebook. The engineering notebook is comprised of defining the problem, generating concepts, developing your solution, building your solution, testing the solution, and then improving the solution. And you go back and repeat in a loop. The engineering notebook is very nuanced. The game changes every year, so your engineering notebook won't always look the same. Now, for the first step, defining the problem is going to be your easiest one. All you got to look at is the objective. What do you need to complete? Then you look at the constraints. What can you not do while you try to complete the objective? All this information will be found in the game manual. Generating concepts should basically be your research phase. What you're going to want to do is you'll search up previous designs of robots from different games, from different organizations, like Vex teams might look at First Robotics teams, might look at Vex IQ, and see if what their function does is similar to that of your game. It is also good to evaluate the pros and cons of each concept, as that allows you to weigh them later in your decision matrix. Developing solution comes right after you deciding what you want based on your decision matrix. Now, you can either plan this out using sketching or CAD software. Now, sketching is very easy, especially if you're a new team or you're new to robotics. But one downside of that is that with CAD software, you can easily scale your materials. You can determine how high you need them to be, and you can already plan out all the materials that you're going to need beforehand. Good CAD software for robotics would be things like Onshape and Fusion 360. Another great thing about CAD softwares is that people upload libraries of parts that come with that specific game or organization that you're in. So very often you don't have to develop your own materials. You can just take those libraries and put them together by yourself. Building the solution is very easy. All you got to do is follow your plan based on the CAD or the sketch. Now, one thing you should do while building is take pictures. Take pictures. How many times have you built Legos before? Usually you have that book where they show you the instructions on how to do it. That's why you need to take pictures. Those pictures are how you built the robot for the judges. The engineering notebook is supposed to discuss how you got your robot from start, the conception, the idea, the identifying the problem, until the very end, which is you actually having the robot built and already tested. And you using those pictures to form a building instructions is basically another way of showing the judges how you got from the start to the finish. You've built your robot. Now it's time to test. Testing basically verifies that your design is good. And if it's not, then it needs to be changed. Everything can be tested on your robot. Your drivetrain can be tested, determine how fast it takes to drive the robot across the entire field. If you've got a thing like an intake, determine how fast it can intake an item. If you've got a launcher, determine how fast it can launch it by measuring how much distance it travels horizontally and how much time it takes to do so. Testing not only helps you, but it helps the judges. The judges are going to see your changes and they're going to say, hey, he did this, but why? You're giving them anecdotal evidence if you're just saying, oh, we changed it because we thought it wasn't that good, or we thought that it was a little bit slower, or you say it's slower. You've got nothing to back it up. You don't have numbers. You need numbers. Talking about numbers, the law of large numbers states as the number of trials in an experiment increases, the average of the results will approach the expected value. Why doing multiple tests are important is because it allows you, obviously, to reach the closer value. But if you just do 1 or 2 or 3 tests, you'll reach a value maybe that isn't close to your average because you have an outlier, which would be something like if something's going too fast, something's going too slow in a test, or if you launch something farther or shorter than it should be. That will really help you determine if you have like a fluke in your testing. Improving your solution is also very important to the design process. When judges look at your notebook, they're not just looking for the fact that you're going through the iterations, but you're actually improving upon your design. Now, you've got your goals and you've got your data. If your data doesn't hit your goals, then you've got to change it, obviously. So you can do this through either like a major redesign of a certain system or just minor tweaks. So this video sums up the basic design process. If you guys have any questions, if you think I left anything out, drop it below in the comments, and I'll see you guys in the next video.